Okay, scatter plots and best fit lines or trend lines. This should be a bit of a review. Should have done some of this in 8th grade. Remember that correlation is a mutual relation of two or more things. Okay, that means that they relate to each other in some way. And there are different ways that we can relate to different things in our data, which if our data is, if the X is increasing as the Y increases, then we have a positive correlation or relationship. If the Y decreases as the X increases, then we have a negative correlation. You can also be thinking of this in terms of slope. And then if there's absolutely no obvious pattern, then you have no correlation. So some examples of this are here in numbers 1, 2, and 3. Right here, our points are really scattered around, and you can't really see like a definite pattern of whether we're going, you know, down from left to right or up as we look at the graph from left to right. So this particular graph has no correlation, just scattered, okay? This one here, if you can see, you have kind of a definite pattern where you could sort of draw a line, you know, that gets close to most of the points all the way through. And then you can see that we have a negative correlation. And it's negative because as the X increases, the Y's are decreasing. Okay. On this one, you can also draw kind of a best fit line through there, and then you can see that this is a positive slope or a positive correlation because it's going, the line goes up from left to right. And as we look at this, as the X gets bigger or increases, then the Y's are also getting bigger, right? They're going up the graph. Here, the Y's are getting lower and getting into smaller values, so that's decreasing over here. So that's negative, this one's positive. The deal that we used on the tables in the previous assignment right here is your calculator stuff so that you can figure out how to find your best fit line or find the equation of your best fit line. So you take the X values and the Y values of each point that is given to you in a table or on a graph, and you input them into that L1 and L2 on your calculator, and then you go back and hit stat again and do the calc and hit number 4, and it calculates the slope and the y-intercept for you. So that's what we need to do when we're looking for our best fit line as we're going through our graphs here. I went ahead and just already did my little graph just to save time. If we look at number 4, Mary is taking a survey of the number of visitors to the beach and the temperature that day. So she wants to see if there's a relationship or a correlation between how warm it is outside and the number of visitors at the beach. So this is the information that she came up with. These are the number of visitors when the temperature was, you know, versus the temperature. So this is your X and these are your Y's. So your X-axis should be labeled the temperature, Y-axis is labeled visitors, And then you need to think about your range when you're doing your scale here. So this is one possible thing that you could do. And then I put each point on there. So what I did is I went to temperature 94, and then I went to a number of visitors, which was right about 610, and put my point. Then on my next point, I went to 84 degrees, and then 225, which should be in between my 200 and 250, and put my point on there. Then I just drew a line that kind of went to where each point was about the same distance away from the line, and to where I'd have about the same amount of points above the line as I did below the line, as best I could. So that blue line is the B. A is the actual graph. And then C, what does your line of best fit tell you about the relationship between the temperature and the number of visitors to the beach? Well, what's important about this is we need to say this, not just X and Y, but we have values, and we're calling the X something. So we need to say that as X is our temperature, as the temperature rises or increases, the number of visitors increases. And then to find the equation of the line of best fit, you're going to use the stat edit, okay? So what you need to do is you need to take a minute and figure that out, and then come back and see if you get the right answer on your calculator. Okay, so you should have gotten, once you went through it all, y equals, and we're rounding to the nearest hundredth, which is the second decimal place to the right of the decimal. So you should have gotten about 3.208 x minus 2,464 and 1,500 for your B. Okay, so when you went through, you should have gotten the A right here, and the B should have been here. So that's the equation of your line of best fit here. You can do the same thing on this problem. I just kind of estimated mine. I made a table of X and Y values. Okay, so my first point here is at 1 and about 9. So X is 1 and 10 is about 9. Then my next point was at 2 and almost 20, so I said 2 and 19. And you can estimate however you want. You can just go ahead and round it up to 20 if you want. So I kind of came up with these points, which got me sort of close to a line. 4 and 30, 4.5, and 32, 5 and 30, and then 6 and 40. So then I did the stat edit process to get the equation of the line, which gave me an A that was like right at 5.5 or close to 6. And my B was going to be like right at about 6.2, or I would call it 6. So the equation of my line would be close to 6x plus 6. And the closest one up here to that is our D. It can't be B because that's a negative slope. And it looks like this is, sorry, didn't use my line. Line of best fit could maybe go sort of kind of like that. That's a positive slope going up from left to right. So I immediately ruled out A and B because those are both negative slopes because these are negative numbers. And then I just had the C and the D left over. Well, the 4x plus 30 just isn't even close, especially that plus 30 with my B. So D had to be the right one. The other approach that you could take is to put each one of these equations into y equals under y1, and then go to your table So you would hit your second key and table, and then you could go through and look and see which points kind of matched up with this. And, you know, which ones came closest, which points in your table came closest to matching what's on here on this graph. So there's a couple of ways that you could approach this problem. Okay, on number 6, we have Professor Stubbs, who is collecting data to determine if the grades scored on the final exams are impacted by the number of hours students spend watching TV. So what I did is your first column is always your X in the table. Your second column is always your Y. So TV hours goes along the X-axis, score goes along the Y-axis. And then I just went by tens here to fulfill my range for the score. And then I just went by ones, but I skipped a line so that I could do the half part, my half hours in between on the lines in between. So right here would be 1.5. And 2.5, etc. Then I graphed my points. So I went to 3 hours, and then 65 was the score, and then 0 and 100 should be up in here, right? And then maybe 1.5 hours was right at 80, so I put my points. That's how I plotted these. Then I drew my line of best fit, which was just kind of going to where I had about, you know, the points are all about the same distance from my line as best I could. And then my line of best fit tells me that as the number of hours watching TV increased, the test scores decreased. So we would call this a negative correlation. And then to find the equation of your line of best fit, you're going to do the stat edit here. Put these under L1 and the Y values under L2, and then do stat calc number 4, and then enter. And that's going to give you your A and your B. So you should have gotten somewhere pretty close to Y equals negative 9.33 plus 95.63. And that's your equation of your line of best fit. That's the blue line right here. And it's just all done with the calculator, so you don't have to do a whole lot of math. The calculator does the work for you. Okay, we have number 7 here, where our coaches of a group of debate teams answered a survey about hours of debate team practices and the number of team wins. The graph shows the results of this survey. So based on these results, if a team practices 4 hours per week next season, which is the best estimate of the number of debates the team can expect to win? Well, I did my best to draw a line of best fit, and it turned out okay, but I'm going to go over here to 4 hours of practice because that's what they're talking about doing. And then I'm going to go up here and like close to this line of best fit is where our answer should be. And so mine is kind of showing right here, but I'm thinking it probably should be a little bit lower. And my point for my line of best fit should be right in here for 4 hours, which would be close to 16. It's not quite going to be at 20. 12 is way too low. And 1, of course, is just ridiculous. The other thing you could do is you could start, make your T-chart of X and Y values for each point, and you could start inputting that data, okay, if you want. So you could have like a 1, 4. I'm just picking out the easiest ones to kind of show you. 2.5, around 15, that kind of thing, and do your stat edit and try and figure out if you can get close to that. But just eyeballing it, I'd say 16 is my best answer for that question. For the rest of the problems, we need to graph your scatter plot, which I've already done. So you need to put your points on here, which means you're going to go to x is 2 and then up 4, to x is 5, up 7, to x is -1 down to -2, 0, 0, which is the origin. Then you're going to go to x is +3 to +4 and +1 to 1. And then draw a line that's going to kind of match up and have, you know, every point about the same amount, same distance away from your line. The next thing you have to do is decide whether this is a positive or a negative correlation. In this case, we're going up from left to right. That means x is increasing as y increases. So that's a positive correlation. And then you need to find your line of best fit, which is you draw it. And then you need to find the actual equation, which is using the stat edit process. So take a few minutes to input these under L1 and these under L2, and then figure out your equation, which should be y equals 1.49x, because you're supposed to round to the nearest hundredth, minus 0.14. Number 9 is the same thing. You need to plot your points from your table, which I've already done. I've already drawn my line of best fit, which puts, you know, an equal amount around my line and about the same distance. The line goes down from left to right, which means that y is decreasing as x gets bigger or is increasing. We call that a negative correlation. And the line of best fit is going to be y equals -0.92x plus 0.03. And we get this equation of the line of best fit by using the stat edit with our table that's given to us. These are our L1 values, these are the L2 values. And then go through the stat edit process, okay? Then on number 10, we're doing the same thing. These are all over the place. You can even put this into the stat edit and it's probably going to like throw an error out at you. This particular case is our no correlation. Because the points are just random, there's no pattern, we can't see a line going positive or in a negative direction. Then finally we have number 11. Draw your line of best fit for your scatter plot. Write an equation for the line. So I'm going to put my line of best fit kind of like that. That gives me about 3 above, 3 below points, my line, and they're all about sort of the same distance away. I'm going to fill in my table with my point coordinates, which are going to be -3, 1. -2, 3, -1, 2. We have a 0, 4. Then we have a 1, 6, it looks like. And then at +2 up to 7. Then you're going to use your stat edit. So we drew our line of best fit, and we're going to write the equation for the line using stat edit. And the x and y coordinates of coming off of our chart, which are from the points. So enter these into L1 and these values into L2, and then do your stat calc and enter. And you should get an equation for the line of best fit being 1.17x plus 4.42. Remember, this equation goes with this line right here, the one of best fit, that matches all our points as best we can. Okay, this line goes with this blue line, which is the line of best fit. Always use your stat edit to find the equation for that. Same here. This equation of the line of best fit goes with our blue line that tries to match up with our points as best we can. Okay, now you're ready for the worksheet. You can work through that. Make sure you get your answers checked by me or whoever is helping out today. Thank you.